Our given equation here is already identified as a first order differential equation, or also known as linear equation. We are going to solve this using that process, but we need to start giving the integrating factor of this. Now this can be solved using separation of variables, but this time we are going to solve this using the idea of linear equation. But then again, we just need to identify first the integrating factor mu of x. We will start doing that by making sure that our given equation is already in its standard form. The standard form for a linear equation is in this manner: d of y over dx plus p of xy equal to f of x. If we have established our equation in this form, we can identify this being any function of x only. And we have here a certain p of x partnered with y on the first degree being our p of x. Therefore, we can identify p of x and f of x in our standard form. We will be using p of x in determining the integrating factor. We will use f of x later as part of the solution. Okay, so let's try to determine our given here if it's already in its standard form. We can see here that our term here is already paired with y in its first degree. This would mean that this is our p of x. It's minus 3, not just a 3, but it should be negative 3 as it includes the sign before it. This item here is, even if it doesn't have any x, that automatically corresponds to our f of x. Now we have identified already p of x and f of x. As mentioned, f of x will be used in a further process. It will be part of a separate video, but this time we will be using p of x because our integrating factor mu of x is identified as e to the power of the integral of p of x dx. So simply plug in here the value of our p of x, the integral of negative 3 dx, and simply integrate the exponent. That would mean our mu of x, or our integrating factor for this given equation when we are going to solve it again on a separate video, is equal to e to the power of the integral of our numerator is minus 3x plus c. Supposedly there should be plus c, but just for the integrating factor we don't need to show that. This is to be used later in the future process. Again, there will be a separate video for that, which will be using this integrating factor at the same time p of x. But for this video is concerned, this is the integrating factor of the given equation. Thank you very much for watching.